Hello, good evening. This is Professor Khan, and this is week 13 of Energy System Technology, EST-204 Heat System Design. This slide is borrowed from the next course, Advanced Heat System Design, and I will go over this in week 3 next semester when you take the follow-up course, but it will be less information, less involved because we already taken 3 weeks doing heat loss calculation. And the reason I left this for the end is I'm sure now you are preparing for your heat load analyst exam, and this will be very helpful, come in very handy. So I'll do two videos. One of them is I'm going to go through the PowerPoint presentation and see if you have any questions, and I will use my Excel sheet as well for the calculation. For next week, I will go over the H22 heat loss book. What information does it have? How do you interpret those equations and this the information inside the book? Okay, moving on. Hold on. Okay, so we'll start with the steps. What do you do? So first thing, you have to have your floor plan. Either you will obtain that from the customer or wherever you are going to install your heat loss in, or you have to go and do measurement by hand and put that on a piece of paper with measurement. So you need the floor plan with the layout for each room, the numbers of floors, which are the heated and unheated space. For example, what's a heated space? A bathroom, bedroom, living room, they're all heated. What about hallway? Usually we do not heat the hallway unless it's an entry hall. And so you have to go and see which space is heated, which is not, so we can include it in the heat loss calculation. It's very important also to know what are the number of occupants, how many people are going to be living there, because that will play a vital role when it comes to ventilation. And I cannot emphasize that more. You need to have the proper ventilation. A lot of people underestimate the heat because they do not account for ventilation for places with high occupants, and that becomes a safety hazard when the place is not getting the proper air exchange. So I will talk also about the house orientation. Why does it matter? That matters when it comes to summertime and the heat gain, but also it matters for us if the house is facing or the windows are facing more south and you get more sun during the day. That might be able to help you a little bit when it comes to heating, but we do not account for that because we have no guarantees that the sun will shine every day. True? Okay. Second thing we need is building material. Building material can be provided in the floor plan, and also can be obtained by going and taking measurement or looking at the wall. What are they made of? Are they studs? There is a drywall. Is there insulation? Is there no insulation? And try to find the factors. If you can't find the factors in the book, or it's not standard or it has been modified, you might need to go and do your U factor yourself. And it's a very good tool to know what or which wall is leaking most heat. Again, we already know that most heat leaks from the ceiling. So it's very important to go and look at the attic and see if it's insulated or not. If not, we might want to recommend that this ceiling should be insulated. I think the recommendation recently came from the Department of Energy as resistance of 32, which is high. So we need really some high resistance for the ceiling or the attic because that's where we lose most of the heat. Okay, the geographical data are also important when it comes to heating and cooling, location, temperature, proximity to water, and also shade. They all contribute to the heating and heating aspects of that house. Okay, so step 2, after we get the floor plan, is to label the rooms because we will do the heat loss room by room. I know some people do the entire house as a big chunk and a big box, but that is not accurate and does not give you the correct heat distribution. So we get the floor plan, we try to decide which is which. What is the bathroom? Is it inside? Is it outside? Does it require heat? And mostly if the room is facing the outside or the wall is facing the outside as we see here, probably that place should be heated. I'm going to try to put some marking in here. I'm going to use the schematic. Okay, hold on. I don't know if I can do it, but anyways. So look at this bedroom, for example, there are two walls in here facing the outside. So this room should be heated and should be included. If we look at this bathroom, same is going to be happening here. What about closets? If the closet is part of the bedroom, for example here, and it's facing the outside, we should heat it. But this is a utility closet, so we do not need to heat that closet because again, it's walking. Actually, it is a walk-in closet, so probably you will heat that. You include that wall inside the room heating, but you do not include this volume when it comes to infiltration. So when you calculate that wall, you will go all the way with the closet because the closet is actually going to gain some heat, and that heat will be coming from the door over here. So again, just to repeat, only walls to the outside. And if the closet is facing the outside, you include that wall in the closet, but you do not include the volume of the closet in the bedroom when you do the infiltration. Okay, what about this bathroom here? This bathroom is not facing anything to the outside, so it does not require to be heated. It's going to absorb heat from its surroundings, so we do not have to heat that bathroom. What about this closet? No. This closet, yes, because there's part of the wall. It's not going to be a heated closet, but the wall will be included in either bedroom's heat loss. What about the porch? Yes, this wall gonna be included because the porch is not heated. So it could be a special case, which is exposed wall, or it's not going to be an exposed wall. It's going to be unheated space because it is outside, but it's not outside. I mean, it's not the same temperature as outside. It's a little bit warmer, so it has a special case, and you can find the factor for that wall as well. Okay, dining area, of course, and kitchen. Laundry, no, HVAC room is not going to be heated. So we gather that this area in the middle is not going to be heated. I hope that makes sense. Okay, moving on. Step 3, hold on, let me pause. Okay. So we already labeled the rooms and we figured out that we have room 1, 2, 3, 4, 5, 6, 6 rooms to be heated inside this house. And again, this is not its own room, it's just part of this bedroom. So we did the step by labeling the rooms, so we can use each room by itself to calculate the heat for that designated room. Moving on. So what is heated, what is not? We already decided that. We said there's 6 rooms to consider. The walk-in closet is not going to be heated and does not have windows outside, so that's giving. And hallway is not heated again. And HVAC room here is again does not heat because it has its own supply of heat. This thing's off, it's okay. And if you look at you can just follow the dot in here. Dining area, living room is combined to one big room. Again, that's an option. You don't have to do it this way. You can do it another way, but I'm just giving you an option to combine this into one big calculation. There's no one right answer for this. Kitchen will need to be heated since it's facing the outside and will not get sufficient heat from the dining area. So it should require its own heating. And also think about the heat distribution. You don't want one area to be extremely hot and one area to be cold. So you want some adequate heat distribution. And if you're going to use hot water system, you have the luxury of doing baseboard radiators along with hot water floor. So it's a little bit more expensive, but it will be very comfortable to pipe a branch out of your own heating system to go underneath the floor inside the room, inside the bathroom or the kitchen and heat the floor. It is not just for feet comfort, actually it's radiant floor heating, which will heat the entire kitchen or bathroom without any obstructions. For the kitchen, sometimes you use a kickboard. It's a board. It's actually a baseboard radiator that's installed underneath the cabinet, and it has a power fan connected to it. Again, it's a little bit too involved, but sometimes it is necessary if you have very small space. So we talked about the kitchen. The porch is included, yet it's not heated because it's treated as an unheated space. So you have a different factor for that. Step 3. So we get the rooms, we get the calculation. We'll do step 3, which is calculating infiltration. This table is just copied from your H22 book, and it's factors for windows with storm sash or without storm sash, but they are new types of windows. So they are either weather stripped or not weather stripped. And you can see that the factor is based on the number of sides with windows and doors in them. So going back to room 1, for example, if there are 2 walls with windows on them, you're going to have 2. So it's going to be 2 walls with 0.026. What if you have 2 windows in 1 wall? Would that be 0.027 or 0.018? It's going to be 0.018 because it's only on one side. Even though it's 2 windows, but they are on the same side. What they are trying to include here, it's a very included calculation because in it comes the wind, the side, the vacuum, the pressure, the holes. A lot of factors goes into this heat loss factor for infiltration. So 3 sides, yes, if you have a lanai or a sunroom, probably you have 3 walls with windows on them. Again, to the outside, not to the inside, and you get the point here. Moving on, step 3 is the transmission heat loss, which is a little bit more involved. So the infiltration is one side. You get the volume, not the area. You get the volume, the heat loss factor from the previous slide, and the temperature difference. So include the floor for the transmission. Well, we will lose heat from the wall to the outside, and the ceiling and the floor. So if the floor is on top of an unheated space, then you will include the floor. If the floor is on top of a heated floor or a heated basement, you do not include that because delta T is 0, therefore there is not a lot of heat transfer. Same thing with the ceiling. If the floor is sandwiched between a heated attic and a heated basement, you do not need to include the floor or the ceiling. I hope that makes sense. So this is what the whole point of what is side do we heat, and then getting the factors from the book. So include ceiling below and heat attic again, include walls in the floor above and heated space. Again, this is just the point of what I just said. So then thinking back into the equation, if that's the U for the ceiling, floor, or the wall, the area to the where you have temperature difference and your temperature difference. If your temperature difference is 0, then there is no heat loss to those sides, and so on. Moving, step 5, so it's moving along. So 1 was getting the floor plan, 2, labeling the floor plan and deciding which is hot, which is not, 3 was the infiltration, 4 is the transmission. Step 5 is adding both the transmission and the ceiling as combined heat loss BTU per hour. So it's going to be BTU per hour. So it's going to be your total heat loss per hour for transmission and infiltration. Step 6 is compensation. If you have a bathroom, you probably will need to add 15% to make up for latent heat and additional heat. Why is that? So in a bathroom, you usually have a lot of moisture and hot water, and water. When water evaporates, because the air is dry in the winter, when it evaporates, it will absorb some heat. So you will have some heat loss as well to make up for drying that water. So by doing so, you will need to compensate in bathrooms by 15%. So you're going to add 15% to the total BTU of that bathroom. Step 7, last step, is once you add all the heat loss for all the rooms and the bathrooms, you add another 15% for cold startup and extremely cold days. If you have a day that's completely above average, you can make up from that. And also, if you want to heat the house, not to keep the house at 70, but to heat it from, for example, 40 to 70, you will need to add 15%. So if you notice, we calculated the heat BTU per hour to maintain the heat, not to go from startup. So that kind of sums it up. You get the 15% for the cold startup extreme days, and also you can use the 15% for hot water demand, domestic hot water. So there are some software that does that for you, but it's really good to know what's happening behind the scenes. And again, those software do not account for oddities like odd walls or new walls, or also not material that's not incorporated in their database. So it's good to know how to make your own U factor, how to add insulation, and so on. Okay, this is an example for the floor plan I was working on. So the first thing, I did the labeling, I did the calculation, and I get the dimensions. So I use the Excel sheet, which actually I posted on the Blackboard, which makes life a little bit easier. So in here, I put the dimensions, and this sheet will auto-calculate the other variables. So you have to, the stuff that are shaded in purple here is the stuff you have to input. You have to put the inside, the indoor side temperature, the outside temperature, which is the coldest temperature of the year, and this is dependent on the location, and this is actually what you want to get. This will be auto calculated, and you fill in the factor for all these aspects here. The infiltration, so probably this is one side of wall. The volume has been calculated automatically. This actually get auto filled as well, and you did the ceiling as well with the factor. Everything will be filled in. Floor, walls are very interested if you have slab. If not, just keep it as 0. Slab usually is in the basement. Leave 0 if there's none. Windows, doors, and walls. And for the walls, I did not put any walls here, so that's going to be a problem. What did I do for walls? Let me see. There was no walls here. I don't know what was room 1. Probably it was not included. Let me see. Wall area, slab, 0. No, it's not here. So this is probably a mistake. But for walls, you're going to fill one of these, not all of them. Either exposed, below grade, or cold partition. That's kind of what's going in the porch. So either one of them, you can do a combination as well. But it gives you the chance to be a little bit creative, and you can put the factor in each one of them. And for this room, you get 22,000 BTU per hour, which is a lot. If we look, most of the heat is lost from the ceiling and the floor, and that is a red flag because you need to account for that and put some insulation. That's something you can work with completely. I'd rather lose heat to infiltration than to ceiling and floor, because that's heat that you cannot. I mean, it's not useful for you. Like, you can lose heat through heat exchange, but you're getting freshly nice, clean air, and instead of you losing heat just for no reason. Room 1, and so I got the rooms. This is actually, there was an empty sheet. This is the house floor. I did get the information completely. You can go through it later on. And I put actually where did I get all these factors from the book. It's from H22 book. And if you don't find it, you can always look it up. I numbered the rooms. I get all the other information. Again, this PowerPoint is going to be posted online for you to look at. And I also put in where does everything fit in. Let me move this a little bit. Yeah. So yeah, I labeled everything. How does it go? And this is a slightly different sheet, but again, try to look at the information and what does it mean. And if you click on the Excel sheet on this cell, you will see what is the equation, what is being multiplied. Okay, moving on. Room 2 filled up. You can see it's a slightly different, but it's the same idea for whatever you need to fill in here. And in this area in the top, and all the areas, DT and BTU. There is no infiltration for this room because probably it has no windows. And I guess that's my guess looking at it. And ceiling, not that bad. It's still it's an area of improvement. The factor is a little bit high. You want something very small. Door and wall. So the wall actually has really good insulation. 0.08 is very effective, so I'm not losing much from the wall. Room 3. Again, I'm still losing a lot of heat from the ceiling and the floor, and I would love for you to go over and try to add some insulation and see what would be the new factor. Okay, room 4, room 5, 6. You can go over and look. And again, at the end, I ended up with total heat loss of 60,000 BTU. I added 15%. Again, I added 15% for each bathroom, but 15% for cold startup. It's around 70,000 BTU hour, which is, again, I think it's a little bit too much for that house. If we consider that we should not leave the attic and the floor with the current insulation. It should be a little bit better. So probably you end up buying a 70,000 BTU boiler, but again, that's a lot. Probably you can, if you insulate the ceiling and the floor, you can reduce that by at least half and get a 40,000 BTU boiler that will do the job properly. Okay. Lastly is ventilation. Again, you have to account for ventilation. A lot of people do not account for that. They just expect you to open the windows. I rather that you have a ventilation based on occupants and a fan that has different CFM and keep that on the whole time. And we say we need 15 CFM for each person living in there. And the DT is going to be the temperature inside and outside. And that's going to be your BTU an hour. And is infiltration enough? No, it's not. So we have to compensate for mechanical ventilation. And if you go in the book, there is a compensation for how much BTU you should add into your boiler for proper infiltration. Okay, I hope this added some to your information. And I hope if you didn't start the project, you start now and ask me questions about how you go about finding the heat loss for a house. It's a very, very valuable information. And I think by this, you'll be ready for your exam. And next week, I will go over the heat loss book and show you how they work out the example that they have, and all the other information you can obtain from the H22 book. I really hope that you have it by now. All right, thank you very much. I appreciate it.